Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Hello, everyone. Welcome to today's AI for Manufacturing webinar. My name is Lihui Wang. I work for KTH, Royal Institute of Technology, located in Stockholm, Sweden. I'm very honored to moderate today's webinar. Today, the topic of the keynote is a next generation cybersecure platform enabling the democratization of advanced manufacturing. We are very fortunate to have Professor Tom Curtis with us today to talk about this topic. Let me provide you the background of our speaker today. Tom is the Chief Manufacturing Officer of the Georgia Institute of Technology, Georgia Tech in short, and the Executive Director of Georgia Tech Manufacturing Institute. At Georgia Tech, he is the Haskell Ramirez Distinguished Chair in Fluid Power and Motion Control and Professor of Mechanical Engineering. He also served as the Chief Technology Officer at the National Center of Manufacturing Sciences. During 2019 to 2021, he served as the Chief Manufacturing Officer and the Founding Director for the Manufacturing Science Division at Oak Ridge National Laboratory. During 2012 to 2013, served as the Assistant Director for Advanced Manufacturing at the Office of Science and Technology Policy in the Executive Office of the President of the United States of America, where he was responsible for coordinating federal advanced manufacturing R&D. He currently serves as the president of American Society of Mechanical Engineers and was the president of a Society of Manufacturing Engineers in 2018. His research focuses on the design and development of advanced manufacturing systems, targeting secure digital manufacturing, additive and subtractive processes, and large-scale production enterprises. He is an elected member of the National Academy of Engineering and is a fellow of ASME, AAAS, and SME. Ladies and gentlemen, without further ado, I would like to welcome, together with you, our keynote speaker today, Professor Tom Curtis, to the virtual podium. Tom, the floor is yours.
Great, thank you, Professor Wang. I appreciate the introduction, and hello to everybody. We've shifted the meeting up a little bit early. It's a little bit early here this morning, but I think that it's quite an exciting time and so forth in terms of what's going on in manufacturing and how it really affects the world. So let me bring my screen up for you to share, and then we will get things going. So I believe that we have the screen up and sharing. Yep, there it is. Very good. So basically, we're going to talk about how AI affects manufacturing today and how we really work through this and so forth. We'll talk about how it's used, how we need to think about it, how it can really help move society forward and some of the impacts it has going for it. But part of really what's going on is how do you take, so democratization really means how do we take that capability in terms of next generation technology, the latest and greatest technologies, and really get them out to society so everybody in society can benefit from it, can make use of it. So let me talk a little bit about my my background, or sort of my goal in terms of my team here at Georgia Tech, and really what we try to do with a lot of the direction in manufacturing. And it really is about innovating at the speed of thought. So you can think about the fact that I have a great idea, and I think everybody knows that, okay, well, if I want to have a startup, or I want to be successful, or I want to make an impact, there are sort of, in my opinion, three things you have to have. I think people always hear you've got to have the great idea. Then you have to have a really good business plan, because if you don't have a good business plan, it's very hard to move things forward. And then, next up, in my opinion, you have to be able to scale things up, to manufacture things, thousands, tens of thousands, hundreds of thousands, millions of items in a cost-effective, in high-quality fashion. And I think you need to do this whether you're trying to, start a company and be successful. You've got to make lots of product, or if you want to make an impact on the world, and for example, you want to get lots of vaccines out, or you want to be able to deploy hospitals, field hospitals around the world, or shelters around the world. You have to make the product cost effective and high quality, and you have to be able to do it quickly. So our goal here at Georgia Tech is really the rapid innovation, sort of ensuring state-of-the-art capabilities in advanced manufacturing. So how do we get it from the benchtop into production operations? And our mission is just to identify, scale up, and integrate critical technologies for new and emerging advanced manufacturing sectors. Could be additive, it could be new materials, it could be measurement systems, whatever it might be. And I will use additive in my talk today to really talk about where we're going in this area, because everybody likes additive, and it's a lot of fun and so forth. So from a technical perspective, much of what we think about is, you think about building up a product layer by layer, and I think many people think about their MakerBot, sort of a gantry type of system. But the reality is, if we take a look over here, it doesn't necessarily mean that we have to build up in this direction. Here you can see one of our 5-axis machines, or actually a simulation of a 5-axis machine, where we're actually using a rotary axis, so we can change the orientation of the build. And so again, you think about this, and it's great. Because think about the propeller, or this paddle that we have down here. You don't need any support structures to make it. You can see that as we make it, we just sort of move along and we rotate to make sure that we're balancing against gravity. Now, as you build this, there are some things that you need to think about. And again, I'll start off with real intelligence as opposed to artificial intelligence. But we ran some experiments initially, and we learned pretty quickly that, gosh, there was some difficulties here in printing these corners, and it shouldn't be much of a surprise that there's less material on the inside curve than on the outside curve. And so when you print this, and this is just a blow up of the inside area, you have to print fewer. You can't go all the way to the inside, so you need to put less material on the inside. So here are things where you basically say, yes, we can start to train artificial intelligence to think along these lines. And frankly speaking, part of the training also comes with what we're training our real intelligence, or our real engineers, to think about. How do we think about these types of problems, and how do we get artificial intelligence thinking about these types of problems to help us move things along? One of the things you'll hear very much from me is what I will call AI, but I will call it augmented intelligence. So how do we use artificial intelligence to augment the human? I want to make it very clear. I'm not interested in replacing the human. I want to augment the human and move them along. And from a societal perspective, this is really the direction that we want to go. And I'll talk a little bit about why it's not just going to be taking the data and sticking it into a black box model and putting it out. And so here, said one example of it. I will show you another example. In this particular case, where we're doing what we call 3D turning. So we're actually using the rotary axis and putting the material down. I should tell you, yes, this is not the speed, and I thought we did have a speed up here. This is probably about 10 or 20 times the speed, so this is not the actual speed of of the processing of this. It doesn't quite go this fast, but you can see the liquid material going down, and we're making this bell-shaped object, and we're using both the fourth and the fifth axes. But what's sort of interesting here, so again, this is just another way of thinking. Think about it, not your Cartesian printing, but this is a cylindrical type of printing. Here we're looking at a conical shape, and if you recognize this in here, this is a probe from Renishaw. So we're simply using a machine that has been out there, or a technique that's been out there for quite some time, decades, where we're just probing the diameter of this part as it's cooling. And what you see, on this probe is that it is cooling. And when my engineers brought this to me, I looked at this and I said, okay, how long does it take until you can touch this part by hand? And they said in about 10 minutes, it's cooled down, enough that you can touch it by hand. I thought, well, that's great. And so if you look at this, an engineer, scientist, and so forth will see a first order response, which is exactly what you would expect from a block of steel cooling down. And so I looked at it and I said, first order response with a time constant, or sort of a settling time of about 10 minutes, 600 seconds. I'm pretty happy with this. So the bottom line is, it's not just about, well, we can build models, but we can use some of our older models, some of our very fundamental concepts in terms of moving this forward. And in fact, a lot of the work that we do here, you could imagine this is just like welding. So we use a lot of decades old welding type of research and so forth. Now, if we take a look at, all right, this is great, but we do have a few other problems, and I'm going to show you where we've got artificial intelligence, and then we have some real intelligence, which I'm pretty excited about. So basically, in this particular case, we're just building up a wall. So it's a surrogate model, let's say, of a turbine blade. And here we're printing as fast as we can. And here we're actually printing. We only print when the temperature of this part drops below a certain level, because if you print too fast, this gets very warm and it tends to fall over and not be very good. And so here you can see the dwell time actually increases as you're printing this part on the left. And so here we've started printing it, and you can see it slows down as we go. And so we're using a thermal imaging camera, which is not particularly expensive, tying into the machine. So the idea is we can actually go back and use legacy equipment if we know how to use it and so forth. And this is some pretty simple AI, just slow down if you're getting too warm. Now, of course, one of the things that you turn around from a cost-effective perspective is you say, well, the problem here is I don't want to slow my machine down. It's an expensive machine, maybe $500,000, maybe $750,000. Some of them can be upwards of $1 million and so forth. So I really want to go as fast as possible. But if I go as fast as I can, I don't really produce a good quality part. And so one of my engineers, Dr. Salibi, basically said, well, if this part gets too hot, let's go print this part. So again, we're bouncing back and forth between two different parts, not unlike how you might do with 3D printing and packing as many parts as you can in your build space. So again, there's some artificial intelligence. How do we run this thing to make sure our thermal models work well? But also there's some real intelligence saying, yes, how do we optimize the machine and so forth? And of course, the idea is over time, you take that real intelligence and you help to transfer it over to the artificial intelligence. But I will also tell you that it is a two-way street. We can also take what the artificial intelligence is using and go back to the human operator and augment that human operator to make them more cost-effective, more effective, in terms of production operations. So let me go and talk a little bit about some pretty cool work, I would say, that's going on at some of our colleagues over at Oak Ridge National Laboratory. And this is some work done by Vincent Paquis and a number of his colleagues over there, really going to the level where you can start to control the microstructure of a part. And so what I'm showing here from my colleague, Dr. Paquis, is he's printed out a bunch of different structures, and this is in the powder bed system. So basically you spread some powder out, you melt it, you let it solidify, then you spread some more powder out, and you keep building this powder bed up. And so you say, well, I want to build these tensile bars down here at the lower level, and then I want to build the same tensile bars at the upper level. And if you take a look at their microstructure, or basically how the metal forms as it cools, they're very different between the two. even though all of the settings are the same and so forth. And so you say, well, why is this? And there are a variety of reasons and so forth, but it really has to do with, it's just a sort of a different situation when I'm down towards the bottom of the bed versus when I'm up towards the top of the bed. And you can use AI to tune your machine so that I change my settings ever so slightly. It's not a very big set of changes to produce the same microstructure. And that's what we're showing. That's what we're showing over here. We actually have produced the same microstructure here in this second set from the bottom versus the top. But this is really where there's a little bit of a cautionary tale with AI. I mean, this is great in terms of we've been able to do this. And I think it might have only been about, I want to say about 15 to 25 experiments to get from this type of microstructure, these two different ones, to these two very similar microstructures. But the difficulty is that if you move these bars around, if these move up a little bit, or these move down a little bit, or they go left or right, any slight, any slight change basically results in a whole different microstructure. So again, the thing I want to really caution about AI is it's very good in very narrow situations, and then one of the things that you have to do is you have to learn to grow the AI, to extend it out, to grow its capabilities. It's not unlike people when they learn. Again, real intelligence. Yes, you see how things happen. You learn by example, and then you try things out. But once you go beyond the examples that you've seen today, of course, we see a lot of those examples, for example, in YouTube and things like that. But once you go beyond those examples, then you're probing the unknown for even the human being, for real intelligence, and you have to figure out on your own how to move things forward and how to work together. I will give you a little bit of a preview. This is really how we see human beings and AI working together. The human being will help the AI to work in the areas that are unknown, but the AI will also provide lots of input to the human, so that they are paying attention to many things at once, and which in general are maybe a little bit beyond the human capabilities. I'll just say this up front: a human is good at maybe optimizing 3, 4 things, maybe 5 or 6 if you're really an expert, but AI can help that human to optimize perhaps 20 things at a time if they guide each other and if they work together. So again, augmented intelligence. Just to give you a little bit of a feel of some of the things that we look at and how this works so well. Really, I'd like to focus here on the left. So on the left, what we have is the tensile bar, and it's an 8-micron resolution in computer tomography. So this is X-ray basically. And then on the right, this is actually the same image, but it was built with a camera that was sitting in the 3D printer. So once again, we're 3D printing. We're 3D printing the part, and we're taking a picture at each level of printing. So you can actually build a virtual X-ray image or a virtual tomographic image, which is on the right-hand side, the red color, versus the left-hand side, the green color. Now, it is lower resolution and so forth, but it's significantly easier to do and less expensive. So now what can happen is the human can work with the AI to see exactly what's going on in the part. And then down the road, the AI can be looking at all of these types of images and really updating the process in real time to move things forward. Of course, again, if you think about it, AI loves images and so forth. And so, one of the things that we might look at is, okay, well, what about people operating the machines? There are lots of interesting things that you could do there. And what we have over here are 2 different sets of images, but we are using similar video and so forth. And in one case, and you can see this video was actually taken during the pandemic. We had our masks on and so forth for safety purposes. And you can see that even with a mask on, even with our safety glasses on, we can identify individuals. And if they're colored in green, we know that that person is allowed to use the machine. Now, I want to point out right away, because I know that there are lots of concerns about privacy and so forth. And so, again, in using this type of information, we have to be very careful to make sure that we enforce privacy regulations and rules and so forth. On the other hand, it is also important to make sure that somebody doesn't accidentally walk up to the machine and for example, start the machine inadvertently by just hitting the wrong button, right? And so again, on one hand, you want to protect privacy and so forth. On the other hand, you want to protect the people that are around the machine. And this can be done, but this is something else that we really need to think about. We can go even further where we can actually see where people are looking. We can see where their hands are. Are they about to hit the start button? And maybe somebody's, maybe somebody is still inside the machine. Are they looking where they should be looking as they're running the machine or as they're hitting the start button on the machine? Again, I want to highlight the fact that privacy is extremely important here. So we're just showing the fact that, yes, we can do a lot with AI, but we also have to be careful in terms of the data that are generated and how we protect those data. In this particular case, it's personal privacy, but in other instances, we may really look at how do we protect proprietary information that, for a manufacturer and so forth, that gives that manufacturer their competitive advantage. But it really is, if we continue on, it really is about, it is about lifelong learning. So what we're showing here, many people who are in the machining area will recognize this as a stability chart. And I won't get into too much detail here, but if you've ever run a machine, one of the things you see is, well, if you run at certain settings, you actually get a lot of vibration and you get a lot of chatter, which gives you very poor surface finish and part quality. And so the typical thing in the past is to say, well, let's slow the machine down. And so we will not speed the machine up. We'll slow the machine down to stop the vibration. Well, it turns out that vibration is really caused by hitting the resonance in the overall machine. And so you can slow it down to get out of the resonance, but you can actually speed it up as well. And so what we're doing here is we just have a simple, I think, $8 or $10 microphone in the machine, and it's listening to the vibration and it's building the vibration chart here. And so the idea really is you would like to be in the area where you have the least amount of vibration. We'll just, this sort of loops through. But the idea here is you can do this fairly automatically. And then while the machine is producing over a period of weeks, months, even years, you can continue to listen to the machine, and it may change slightly, and you can update your, your model over here. And I think a key thing here is, look, machine never stops learning. Why should people? And so I wanted to point out, and I do find this sort of interesting, that there are really 10 types of people out there, right? And those 10 types of people are, those that understand binary and those that do not understand binary. And if you think about that, of course, all of the computer science will laugh at this statement. But the reality is what we're seeing now is from a training and educational perspective, we do see that computer scientists who have domain expertise, for example, in manufacturing, are in much better position for steady and stable jobs than just those who are only in pure computer science. So some domain understanding. The other one is we also see a lot of the engineering types, in particular manufacturing, for example, my experience area, that have much more capability in computer science. And so these tools are available, for use. And so from an educational perspective, making sure people understand how to use AI types of tools. But the reality, and this is my colleague Scott Smith over at Oak Ridge, we were PhD students at different institutions, but 35, 40 years ago, his statement is, look, we used to put sensors on all of our machines. We would spend months putting sensors on the machines. We would maybe run the machine for a week or a couple of weeks, and then we'd spend weeks analyzing the data. Today, all of those sensors are in place on modern machines in production systems. So every time a cut is made, just like over here, every time a cut is made, it's like running a PhD experiment from several decades ago. So we're continuously learning, and every cut is an experiment. We're learning from it, just like we do in real life. So in terms of upskilling, and it's even sort of really rethinking. You say, well, yes, how do I put additive into a machine tool for hybrid and so forth? It's really thinking outside of the box. So in this particular case, we have a robot that's used to load and unload the machine. And instead of having the load and unloader on there, we actually have it with a weld head. So it's actually putting down metal inside of the machine. So it turns out we can take some of our older equipment and really utilize it in a very new fashion. So this is a 1980s CNC machine tool, and we're using it. So now what I'd like to do is pivot a little bit to the AI and sort of think about how we move forward and really culturally and mentally how we need to pivot to think about AI and to really leverage it to really improve our current situation globally. So I'll give you an example that many of us really, I'm sure, have used. And if you've used Google Maps or Apple Maps and so forth, you've used AI. And there's a lot of data coming in from phones that are traveling up and down the highway. In this particular case, I'm showing a US interstate that give you information about what's going on real time on the highway. And there's a lot of machine learning going on. What's the best path? What's the best path at the appropriate time, et cetera, et cetera. So a lot of good things going on there. But let me point out something, and I think we've probably all seen this. So I was driving the other day, and Google Maps said, okay, well, get off at this exit. And I was thinking to myself, this is not the exit that I need to go. I need to go all the way up here to this particular exit. So maybe there is an accident or there's a traffic problem and so forth. Fine. There's real-time sensing that Google Maps has. I will get off. And then as I got closer to the exit, I looked at what Google Maps said. It said, get off at the exit, cross the road, and then get back on. So it was getting off a detour of maybe a few hundred meters. So I took a look at that. And I said, well, maybe there's an accident right there at the exit ramp. And then as I got close to the exit ramp, I looked up and I didn't see any traffic. I saw that the traffic was flowing straight through. There was no blockage and so forth. And so I decided that, maybe there was a mistake here. I should go straight ahead. And certainly I didn't get off on the exit and I kept going straight ahead and there was no accident. So in this particular case, for whatever reason or other, AI has failed us. But the real intelligence, the driver, myself in this particular case, saw that it wasn't necessary to get off. So I'm using my own set of sensors, which in this case was just my eyes looking forward and understanding, yes, this is just an error that we sometimes see. I don't know why, but we correct for it. So this is real intelligence working with artificial intelligence to give you the best solution. So these are the types of things really that we look towards and sort of working together. And so now I will give you an example of how you need to think about some of these problems. So very much in manufacturing, people say, well, I want to use AI to pick out the bad part. Please, let's pick out the bad part and so forth. And you know, the real question is, well, okay, for AI, and I think most people do know this, and if you don't, it's a good point to understand. AI needs what is one of the most important things that AI needs? AI needs data. You could say, well, it needs good data, it needs very curated and then labeled data and so forth. Yes, but it needs a lot of data. So the first thing that happens when a company says, hey, can you help us to use AI to pick out a bad part? I ask them, how many bad parts do you make? And their answer is typically, well, you know, 1 part of every 1,000. That's not a very good situation. It might even be 1 part of 10,000, 1 part of 100,000, or perhaps even a part per million. And so if you're making very few bad parts, you don't have a lot of data, so it's very hard to detect, to train the network on the bad part. But what you do make is a good part. And so in this particular case, what you really want to ask is, don't use AI to pick out the bad parts, but tell AI to pick out the good parts. We have a lot of data. We can train it. It can tell you what a good part is. If a part is not good, it doesn't mean that it's bad. It just means that it's not good, perhaps, and that we should take a look at it. So that's where we should focus our real intelligence on. And that's what we're showing over here. So in this particular case, this is a welder. It's a fiber optic welder. We're looking directly down the fiber optic at the weld pool, and we can actually see where the weld pool is good or bad. Actually, where the weld pool is good. If it's not good, then we might highlight it in yellow and say, hey, we might have a problem here. So if I take a look at my next slide, this is a weld pool that is not good. Here's a good weld pool, so we might identify it. And what we wind up in the end is, yes, you do wind up building up your data for bad. We wind up saying, yes, this part is good here. In red, this part is bad because we know it. And then maybe in yellow, this part we don't know. So let's bring in the real expert and sort of work on these types of things. So again, it's the question that you ask and moving it forward. And really, again, as I mentioned before, and I'll just go a little bit further on the whole welding part, because this is the additive, the metal additive part. these are all the different, I shouldn't say all, these are many of the different things that could go bad when you're building a metal part. So we have 23 dependent variables on the on the additive process. And I won't go into these, but the idea really is for a human to try and track all 23 of these is difficult. So what you want to do is you want to let the AI track all 23 of these things and let the people really leverage where they excel. So they know about the most important one, and let's guide the AI in the right direction. Or if something comes up the AI doesn't understand, let's send it over to the human. So it's really the human and the AI working together. And there's a lot of great things that you can do with this type of capability. So in this particular case here, we're making this fairly simple part. And even here, we've got calipers that we're making a measurement with, and they're Bluetooth enabled calipers, and they tie into your smartphone or a tablet or the Bluetooth dongle on the machine. So you make a measurement, you say, okay, I've made my measurement, and that measurement is uploaded. So now we have digitized the data. We eliminate somebody punching in a wrong number or recording a wrong number or reading a wrong number. But we have that person maybe make 5 or 6 measurements, and we take a look at their distribution. So the first thing we can do is we can start to take a look at this distribution. When you're a novice, you have a much wider distribution on your measurements. And then as you go along, you get a tighter distribution. So we can look at the person's learning curve. Again, I want to highlight the fact that we have to protect privacy, but the idea here is not to blame somebody for not doing a good job, but to understand if they're having an issue with it and to help them with their training and also understand the human process. I think in general, we know that human beings are the biggest source of variation in a process in manufacturing. And so we'd like to quantify that and help them to reduce that variation. A couple of other things, here in terms of just facing off. So this is the saw cut blank. And then in the end, you turn it on a lathe. And so you have concentric circles. Actually, this is a spiral. I don't think it's a big stretch to say, well, gosh, yes, I can have my AI determine the difference between a line and a circle. So, for example, if I have cleaned up this part and we've really gone through it, instead of a bunch of lines, we have circles. If there's a little bit of lines left over here, that means we haven't cleaned up our part particularly well. So the idea, again, is that we can use the AI to augment the human. You can put your safety glasses on, which you have to wear in the shop, and it can look when the person is taking the part out of the machine, did it really machine accordingly? And sometimes a human being will miss that. And so we can just highlight that for the human. It's not unlike driving down the road. I think most of us recognize that a stop sign is an 8-sided, it's an 8-sided polygon, an octagon, right? And I think we've probably all been in the situation, we might have been distracted and so forth, and we've just missed the stop sign and we've gone through a stop sign. Now, hopefully you go through that stop sign, you don't cause an accident and so forth, but I think that we've probably all missed a stop sign or two, and maybe even that we haven't even seen the stop sign. So we don't even know that we've missed it. If our forward-looking camera sees an octagon coming down the road and just highlights it to us, let's say in our heads-up display on our vehicle, well, now it says, hey, there is a stop sign here. The car doesn't even have to take action. It just tells the driver, hey, there is a stop sign. Let's slow down. And so that's really what you're looking at. Now, as a little bit of a cautionary tale, what we see over here is actually the spindle speed. So we can actually get data off of our machine. And in fact, what we see here is here's a part being made, here's another part being made, here's another part being made. And you can see the individual is getting comfortable with the machine and the part. Again, I want to caution, we're not looking to track people, but we're looking to see if they're learning the process and they're becoming comfortable with the process. And if they are, that's great. And if not, then let's work with them to give them some more training to make them a better workforce. But I will caution you that if you expand one of these, you can actually see what's going on in the machine. So even getting your sensor information and recording this type of information gives you information about the process. So you do have to protect the data from a privacy perspective from both people as well as a process perspective. If this is proprietary information that you don't want to get out, because this information here gives you exactly the geometry of your part. You can back that out. So I will talk about in my engineering system, my grandmother cell phone, but actually my mother, she's 85 years old, and I'll use her as an example in a couple of examples here. So one is she really turns around and when she heads out, she says, and I think we all do this, we go and we say, what's the weather? We might bring up the weather map and so forth. You're getting, in terms of generating those data, those data, 17 satellites, NOAA satellites, are generating weather data. They go into, generating terabytes of data, going into 5 different machine learning models on 3 different supercomputers. They actually use multiple Doppler weather radar, images and data, and sort of integrate it all together just to get the weather. And so if you think about it, well, how are we going to get the workforce? How are we going to get people to use this? We already are. So you've got to make it move forward and sort of, really link it all together. And how do we do this? If you think about this, if you go through a plant, if you take a look at a CNC machine tool, if you take a look at a robot or a heavy piece of equipment, you see a lot of that capability already there. You see Windows XP, maybe some older material and so forth, but you see Windows there. So a lot of the infrastructure, many of these plants are online and so forth. So you see a lot of the infrastructure in place. Again, I think the biggest issue is how do we leverage that infrastructure? You saw we were controlling that machine based on the temperature of a part. That is an older controller that we're able to integrate together. But we also, again, have to protect the data. So the capability to integrate, to use it is out there. It's just how you move forward. So given what I would say are some of the building blocks for democratization, we can get design information, we can get process information back and forth. When I make a part, so I show a little turbine blade over here, and every one of its areas, I've got information on how it's made. So this is basically a digital passport. Did the process that I used to make this turbine blade, for example, did it follow the right procedures and protocol? Is it good? So I produce a part that is already proven to be good. So it comes with its own passport. We can do this even with older systems. We might do things like extended reality, as my colleague is over here, to really help to leverage that human individual. We've got to store that information in secure locations, cloud locations and so forth. How do we integrate those together? Every machine might be a little bit unique, and I think we all know that. You might have driven different cars, and even though it's the same type of car, it might sound a little bit different. Or you get into your car in the morning, you turn your car on, and something doesn't sound right. That's real intelligence telling you, yes, this thing has changed a little bit. How do we leverage that? How do we work together? Maybe it's really a new business model. So let me just say, we might do something like, I've got a company like General Motors, and they need 1,000 parts the next day. And so they may have a supplier close by that can build those 1,000 parts. It's a very large supplier. But we might also think about something a little bit similar to Uber or Lyft or the rideshare, where General Motors says, hey, I need 1,000 parts tomorrow. And there might be 20 smaller companies around General Motors, or the OEM, whoever it might be, 20 companies that say, yes, I can give you 50 of those parts tomorrow. GM sends out all the data to make the parts. The orders, all the raw material is ordered independently and shows up at the plant. You have to load the tooling, you have to set up your machine and so forth. And one could argue, well, great, we'll have all the robots setting the machines up and the whole bit. But the reality is, that's not easy, that's expensive, and it's sort of hard to do. People talk about the lights out plant. I can tell you that your typical lights out plant does operate really in 3 shifts. And it's typically the 3rd shift, the one that runs, let's say, from midnight to 6 or 7 o'clock in the morning, that has no people in it. But it's a little bit of a fallacy, because the 2nd shift, the one right before the midnight shift, is where you have a lot of people loading up pallets and loading up machines ahead of time so that all the machines can run through the night. When you show up the next morning, the 1st shift at 6 or 7 o'clock in the morning is unloading all of the machines. So you still have a lot of people in there and so forth. And by the way, they also talk about, running, without people. That's if everything goes well. If there's a problem, if you have any type of issue, you need a human being in there to really correct for it. So again, humans aren't going away, but how do we extend them? How do we make them better? In this particular case, it's really difficult to be working between midnight or 6 and 7 o'clock in the morning. People don't want to do it. It's a difficult job. So can we basically have more people working during what I would call more regular hours and let the automation take care of the time of day when people are really not excited to work, and it's just not sort of beneficial to be working at that time frame. And in fact, actually, typically we pay more for that third shift because nobody really wants to do it. So again, it's just like a rideshare example. GM says, hey, I need a bunch of parts. Just like you said, hey, I need a ride from the airport to home. Uber or Lyft or rideshare will connect the customer with the supplier. So there's a driver that wants to take me home. Now, 30 years ago, that taxi driver, she had to really know all the routes to get me to home. It's easy to get to the airport. Everybody knows how to get there. But to get to somebody's home is a little bit more difficult. And then that taxi driver, she also had to know how to avoid traffic if it was rush hour, or you might be listening, maybe there's an accident and so forth. So lots of difficulties. So rideshare example, I say I want to get home. The rideshare app says, this is what it's going to cost. This is how long it's going to be. You accept it. So now you put the contract together. This actually even guarantees you quality and so forth, and you can track your ride. It makes a connection. And now that rideshare driver, she doesn't necessarily have to know the best route home because Google Maps or Apple Maps or whatever is going to give her the best route home based on real-time information. You still need the driver. There's no doubt about it. You still need the driver, and one could argue, well, we're going to have self-driving cars and so forth. I will grant you that, but that's still pretty far down the road. And I think we're going to have the drivers for quite some time. So you still need the driver. They can get you home. You still need the person to set up the machine to make the parts and maybe load and unload the machine and so forth. So the people are still there, but we make their lives easier. We make things connected together. So the idea is leveraging and extending the capabilities of that well-trained workforce. Now, one thing I really want to point out, and this is where we need a cultural shift. And I will go back to my mother, who basically the other day called me up and said, I wanted to mail you a package. I measured the size of the package. I weighed the package, and I called up the post office and I said, I want to send this package. Here are the dimensions and the weight of the package. How much postage do I need on it? And the person at the post office said, I don't know, you have to bring the package in. And my mother said, well, somebody must know. And so she went through 3 or 4 people before somebody could give her an answer. And it was very frustrating for her. She said, I don't understand. Why can't they give me an answer? Don't they know? And my response to her is, well, the scale that they use at the post office now, you put your package on the scale, it weighs the package, but it also measures the package in terms of its dimensions. So, and then it provides an option. Here are the different options for delivery that the postal person can give you, and you make your choice, and then they print out the stamp or the sticker that goes on the package to mail it or to ship it. And so the reality is now you're getting better service. The person who is running that machine doesn't need the same type of training as 10, 20, 30 years ago. And, my mother's thinking is, well, gosh, they've really made it sort of simpler. And don't they, and so they don't need that, that smart person there anymore who could do all of that. And my answer is, yes, you could look at it that way. But on the other hand, we know that we need more. You take a look at unemployment, we need more people in the workforce. And what we're doing here is we're enabling somebody who doesn't have that particular skill set to now work in this area and to execute the same job, which is a higher paid job. It is a better job. And by the way, with AI working with the person, this actually probably generates fewer mistakes than the expert of 10 or 20 years ago who are actually doing these things manually. So again, we're taking somebody, and this is a culture and mind shift. We're not watering things down. We're not making things easier so we could just employ anybody. We're giving people an opportunity who don't have a skill set to really move up and to take some higher end jobs. So we're augmenting their skill and capability. And of course, the big question is, okay, so if we do that, when am I going to lose my job? And that is sort of a big question. And I have to say, this was, well, probably 15 years ago now, maybe even a little bit longer. I was testifying in front of Congress, and I was asked, in particular, we're talking about automation. I was asked, when will I have the robot that will load and unload the dishwasher? And there were I think 3 or 4 of us testifying that day, and the person next to me was an academic in computer science, and he said, well, that's going to be in about 10 years or so, we should have that. But I think the reality, and again, this is where you need to have some domain expertise. I think that person really had not spent a lot of time with robots and making use of it. You have a dishwasher, this is hundreds of dollars. You have a robot, this is thousands, tens of thousands of dollars. If you've ever tried to get a robot to even put a peg in a hole, it's a very difficult task. You need to do a lot of work and so forth to get it to behave as good as a human. Now you want it to stack your dishwasher, which is very difficult for a robot. The next thing is, if you've ever used a robot, they're for industrial purposes and so forth, to have them handle your dishes, your fine china, I wouldn't want to do that because I think that there would be a lot of broken dishes and glasses and so forth. So again, the human is great. And then also loading and unloading is great, but you've got to put the dishes away in all the cabinets up here. So is the robot going to be able to do that? I also know in my particular dishwasher, it doesn't clean off mustard for whatever reason or other. If there's mustard on the plate, it will not clean off the mustard. So I visually scan, and if I see mustard, I rinse the mustard off before I put it in the dishwasher. If I miss it, when I take it out of the dishwasher, I see there's still mustard left over, and then I clean the plate again. So again, the robot's not going to do this. And they say, well, we can program it to do this, but this is a very difficult task. So the human is still there. But what we have done is we've eliminated the issue of washing the dishes. So the dishwasher has gotten rid of the tough part, or what I would say is the, least fun part of the doing the dishes part. Yes, I still have to load and unload the dishes and do some inspection and so forth, but I'm much happier doing that than actually having to wash the dishes as well as put them away, inspect them, et cetera, et cetera. So the idea really is we're augmenting the human. We're taking away some of the tougher jobs that people really don't want to do and giving them better jobs. And I have to say, frankly speaking, again, we take a look at some of the demographics around the world, and we see that we are losing our workforce. The workforce is aging, and I think this is going to really help us and help us move forward. So let me bring up my last slide and sort of wrap up. One of the things I will show you is, so down at the bottom, this is a system called Medusa, and this is a big rotary system, and we've got 3 robots, and they're building this larger part. This table will rotate around and so forth, and they'll work. In this particular case, they're working independently. In this particular case, a simulation with 4 robots, they are actually working together to build, in this particular case, a square type part. But the idea really is we have simulation. We could do a lot of things offline, but ultimately, you've got to go off and you've got to build this thing and make it move forward. But the idea really is in terms of the big picture, and it really does get back to this whole democratization. So let me build up to my last point there. But the digital thread is a two-way street. So we've got a lot of information coming out. We can get data for machine learning and AI. So that's very important. But we can also use it to help augment and train the workforce. And we really see some interesting things in terms of virtual reality, augmented reality, any of the extended reality. So it's not going to take away jobs. It's going to make the workforce more value added. It allows us to deploy rapidly, what I say is faster than the competition, but to really deploy at the speed of thought. I have a really good idea. How do we get that capability, that process capability, that new design, that new product out there? So we can learn from previous deployments, from previous production operations, excuse me, from even previous people. You know, we've got experts out there and people are very concerned. My expert is going to retire. What am I going to do? Well, let's learn from that expert and help the next generation to move in and make them experts and so forth. I think there's this whole thing. We haven't gotten into a lot of generative design and manufacturing, but sort of the generative is, well, let AI solve the problem. I think this is completely incorrect. AI is not going to solve the problem. You have to have the human. Now, maybe in a long time from now, and in certain areas that will work. But I think in many areas, you've got to have the human working with the AI. The human knows where they want to go. Let the AI help the human. Think about the 20 other parameters that you want to have optimized, but let the human drive this forward. This is exactly how Google Maps work. They're not figuring it out without human input. They're tracking phones moving down the road to see what alternatives people are taking. They're learning from people. So make no doubt about it, that AI on Google Maps or Apple Maps is learning from people. Humans will provide the starting point, whether it's on the learning aspect of it. Yes, how do we train our AI? How do we expand our AI? Or even how do we work with AI or automation? So again, loading and unloading the machine. People are very good at that. There's a lot of discussion about self-driving cars. I think you're okay on the interstate, but once you have to get to a parking lot and you have to determine which loading dock you go to, where are you going to park your vehicle, will it fit in a certain spot and so forth, I think that's where the human takes over and says, yeah, there's a lot of detail there. And again, we see this even in driving the car. Blind spot detection, adaptive cruise control. So the human is still in the loop, but we've made the human a much better driver in terms of their capability for driving. Clearly, you've got cloud and edge. I think people are familiar with how we're going to do things in the cloud and on the edge. Fog is where the cloud comes together with the edge. And we really need to design systems that can move between the cloud and the edge through the fog for both compute. So as they get better cloud computing capability or edge computing capability, we can shift back and forth. Communication, many of our production facilities are now pretty well connected via storage and so forth, via broadband, et cetera, et cetera. Certainly with 5G coming along and now deployed, so much easier, so a lot easier. Although I would say, if you take a look at this, you see this welding operation that generates a lot of electromagnetic interference. So maybe not as easy in certain areas. And then storage. Yes, we can store a lot of data. Does it make sense to store the data? And how do you curate the data? So it's not just taking data and store it. Again, there's a big difference between data and information. But we also need to do things in particular in terms of protecting that proprietary information. So, or protecting people's personal information and so forth. So that's just a caution. We've got to make sure that we're secure, but we also need to do that to make sure that we protect that information. And in the end, really, I see this as allowing us, to grow the small and medium-sized enterprise. So this is what we would say is the backbone of the middle class. Instead of having that one big plant that can make 1,000 parts for GM, we have 50 smaller plants that can make 20 parts. And by the way, if one of those 50 plants has a problem with COVID or a flood or power outage, you still have 49 other plants. So you have a much more resilient production capability. And they're also local. So this also really grows local manufacturing capability. So is it good for the export-import business? Well, perhaps not, but it brings things to point of consumption, point of manufacture, which is great. So I will wrap up here, and then we can go to some Q&A with sort of a final thought. And this is really in terms of, where do we need to go with people? And I will say this, and I think that we are moving in this direction. But what I'd like to do is highlight a statement from a 20th century philosopher. It really is about how we're going to integrate that workforce together, how we're going to really change how we think about AI and working together and so forth. And this is from Eric Hoffer in the 20th century. And he said, in times of change, learners inherit the earth, while the learned find themselves beautifully equipped to deal with a world that no longer exists. So the bottom line is, yes, technology is changing and moving along, and we've got to keep up with it. Eric Hoffer was correct in the 20th century. I think that rate of change has accelerated. And so I think that this is even more pertinent today as we approach the middle of the 21st century. And so with that, I really want to say the investment needs to be in people to leverage that AI and to move things forward. So with that, I will thank you and be happy to answer any questions that you might have.
Thank you, Tom. Excellent presentation. I think you touched quite a number of different important things that we need to take back and consider it. Your presentation talk about the AI, augmented AI, how this AI can help us, or augmented intelligence to help us, and eventually we can make a better decision. You also used quite a number of real-life examples to walk the audience through to have a better understanding. This is really excellent. The online audience, you can raise your questions by typing your question into the text box, so we can see them. While you are doing that, perhaps I can start with a couple of questions here. Mm-hmm. continuation of the augmented intelligence, Tom, you talked about, which is quite interesting to me. In one way, the human real intelligence can help AI to learn, so the model will be more accurate and reflect the real situation, adapt to the reality. On the other hand, the AI algorithm and solutions can help human to make a decision. You mentioned this can be done in offline mode or can be done in inline mode. Eventually, human need to be in the center of the loop. That's the human centricity we're talking about. In a real industrial application, how this role can be divided in different situations. Sometimes the AI can take a leading role. Some other times the human need to make a final decision. How to make this systematic for the practitioners to use? Can you comment on this?
Yeah, I know. I think it's an excellent question, and I think there are a couple of different modes that you look at. So, for example, what we've seen in production operations is the AI might start to lead you along a path, and in general, the AI, it doesn't like to. You want to keep it from extrapolating. You always want to interpolate. My data set is here. You want to operate within your data set. So the first thing is if you start to get towards the outside of the data set, as you move in that direction, what we do is we track that and we say, okay, why is the AI moving in that direction? Now, it may be that there is some solution out here, that is better. But then that's where we send it over to engineering or research and development and say, let's take a look out here, because now we're operating outside of the bounds of what we know. And so maybe we learn something there. The other thing really is, and by the way, if there's something going out here, we can go to our engineering teams and say, well, let's gather data over here so the AI doesn't go out there blindly, and let's provide the AI with the data and see if it goes in that direction. On the other hand, so AI could actually help you think about and do things. But you have to be careful that it's not hallucinating, if you will, in the wrong direction. I think on the other hand, you can also turn around and say, well, let's make sure that the AI is moving in this direction. Or if it's human says, well, hey, we think that this might be a good area over here, you can actually use the AI not only to see if it makes sense, but to help you develop some experiments. So the AI may say, well, hey, we don't have a lot of data here. Let's try here, here, here. So you link that with more classic design of experiments to feed that into the AI to see if your model is refined. So again, there are a couple of different modes. Certainly, if you're in manufacturing, you don't let the AI, you don't even let the humans go way off, but you see what the tendencies are, and you sort of keep it from going too rapidly, because you do want to be conservative in your production operations. Yes.
Mm-hmm. Yeah, along this line, of course, AI has the learning capability will be stronger and stronger. On the other hand, will this really affect humans' skill development? For example, if we use a calculator, we don't really know how to calculate by hand. We rely on the calculator. We use a word processor. Our spelling capability is down. Of course, our experience and skill set are collected through our practice. If this AI, especially this generative AI tools, are used more and more, we may not really do the actual work. We lost in the process. We get result directly. So the human intelligence, in a sense, may be reduced in certain aspect. So my question is, will the AI, the artificial intelligence plus real human intelligence together will be greater than 2 or less than 2 in the future?
Yeah. And I think that's a great question. I think we could also even talk about finite element analysis. I think one of the difficulties we have had in education is, well, I've got a finite element analysis package. I really don't need to do statics anymore. But I think the problem there is when people just believe what the computer spits out, or the calculator, right? So it's a great question to with a calculator, if you put the decimal place in the wrong spot, it can give you an answer. And if you're not paying attention to things like order of magnitude estimation, you can really have a problem there. So I think, and when we teach this, because I think a lot of students say, well, why do I need to know this? Because I have a calculator to do this, or I have AI to do this for me. I think the idea really is that, yes, it's not perfect. It makes mistakes, just like Google sends you off the exit ramp and then right back on the next entrance ramp. And so it's the fundamentals where you look at these things and say, yes, it makes sense. Now you could still get things wrong in terms of some of the details, but I think in terms of some of the, but that's where AI, I think, does well is in the details. So I think that part of our educational approach really needs to be, look, in order to be successful, you need to understand some of these very fundamental issues and know what to look for and so forth. We could go on and on. There are lots of examples where, I think the senior people have sat down and they have models that have come out from supercomputing, hundreds of hours of supercomputing time, and you look at it and you say, well, it just doesn't make physical sense. And that's really what we need to have our students think about, are the fundamentals. How does it relate to the real world? Let the AI deal with the details.
Thank you. Thank you for the answer. Now we have one question from the online audience from Paige Donner. It sounds like you are making a cake for decentralized manufacturing enabled by augmented intelligence. Did I understand it correctly?
So I think that there's a great economic case for and I think you have to be careful about what you mean by decentralized. So there are a lot of things linked together and so forth, but I think the reality, if you talk to an OEM or a customer, they would like to have a distributed supplier base. The reason that you don't want to go around with a distributed supplier base is I've got a really good supplier that I trust the supplier and so forth, so I want to use that supplier. But the reality, why you use at least 2 or 3 is because if there's a fire here, then you lose your supply base. What if you could trust all of your suppliers equally, and you really could get every part that you can, is good. Now you could distribute it out. So now you could actually have some very small, 5, 10 person shops that could supply. So it gives you much more, it spreads the wealth out. It provides local manufacturing. So if I'm making it in the US, right, if I'm making it in China, we will, supply locally, because if I can just order something and I get it the next day, I can't get it from 1,000 miles or 1,000 kilometers away. That being said, the digital link, allows you, let's talk about 3D printing. I've got thousands of 3D printers making similar parts all around the world or all around the country. How can I take all of the data we're learning from it, upload it, build a more global model, but realize that every one of those machines is slightly different. So there's local things happening, there's global things happening, and we can use AI to tie a lot of that together. So it's not that you have completely disjoint, but really sort of the digital thread or the digital network brings a lot of that together. You could almost say into a more unified manufacturing operation, but yet still the wealth and the capability is distributed, as is some of the learning and so forth.
Thank you. So I hope Tom answered your question page. Otherwise, you can send in follow-up questions. Now we have another question from Jin Cui. In lighting both the technical and the policy aspect, could you please share more about whether there is mature or standardized process to implement privacy and ethical principles regarding AI, augmented intelligence, or will be one in the future?
Yeah, so and this is a great question. And I think, in many instances, I think it's very, a lot of this is very cultural in terms of where you are in the world. And you can see this in terms of what defines privacy in different parts of the world and so forth. And we won't get into whether one is better or not, but some of these things, some of the different privacy constraints, are going to, and data constraints are going to drive how things move forward. Data and ownership and curation. One of the big things really is, I've got a bunch of data, but how do I curate it? How do I make sure it's, good data? And then how do I share it? But not just I will share it or I won't share it, but how do I selectively share it? And so how do you move this forward? And it is difficult, even in education. I've got I had a colleague who teaches numerical methods, teaches programming, and he said, he sent his homework to ChatGPT and it came back, programmed it in MATLAB and C, and he said even Fortran. He said Fortran was a little bit longer than everything else because it's not a super compact language, but he said, so what's to stop students from doing that, and saying, yes, I did that. And so we do have to think about that. But I think I won't say that this is the solution, but look, if you have an oral examination if you have one-on-one, this is back to sort of very old school education, but one-on-one with the professor and the student, I think that it's pretty hard to insert AI in there. The student has got to give you the answer and so forth. And by the way, this mimics in terms of a design review and so forth. When you're up in front of leadership of industry or government or whomever, and they are asking you questions in real time, you have got to know your information. Again, hard to justify, right? Hard to say, well, yes, that's 20 years down the road, but today I just need my homework done. But we really have to rethink how we do education and how we train the students to engage. But I still think our educational goals are the same. They need to understand the fundamentals. They need to be able to think in real time and respond to difficult questions that may be outside of our data training set. And so how do we do that? It's a good question. And I think that we're going to see some advances over in the academic side and so forth. Yes, certainly some computer programs that'll help protect us and so forth. But I think it's going to be a cultural shift. We're going to have to really think about how we change things and how we engage both the students and society.
Great. So final question from my side. Regarding privacy, you mentioned the privacy data. Most of the privacy data perhaps related to humans in this sense. In that case, there's some intelligence, human intelligence really embedded into the privacy data. I think the company or industry, whoever the owner is, wanted to fully use the privacy information within the organization, within the company, right? And on shop floor, there's no need to properly protect, or protect is for leaking, but inside they wanted to fully use it. So this boundary can be shifting, depends on the collaboration mode, whether it's one factory, several factories belong to the same company or goes to the suppliers. How's the strategy company really taking to control or protect privacy data, especially the real intelligence?
Yeah, I mean, I think this is an excellent example. I think you've got an OEM, GM or Daimler or BMW, Boeing, and they've got a bunch of suppliers. Of course, they would like to see completely into the supply chain, what the costs are, what the times are, everything that's going on, who's doing what. But I think the companies that are supplying them, they need to say, look, we're giving you a product that is good, but we don't want to give you all of our costing information and so forth. And, that's proprietary. We already think about this and we protect it, but what we have to do is make sure that we don't unintentionally give away this type of information. On the other hand, we've all heard about job security. So I work in a plant and I'm the only one who knows how to do something. And so my job is secure because, and I want to make sure nobody else knows my job, because if they get rid of me, right, then if they fire me, then they can't produce this part. So the reality there is that's not particularly ethical, either. On the other hand, you want to make sure that, well, we're not just learning it so we can eliminate you and lower the hire somebody at a lower rate, so forth. So I think that there are a lot of different ethical issues, whether it's from a personal privacy or corporate privacy, that we have to make sure that we put some of these business models in place and ethical models in place. And this is where it's very interesting. So I talked to, so for example, at ASME, we have conversations about ethics and, what are ethics? And people say, well, good when, it's sort of good and so forth. And these ethical, standards or, morals, they run deep. But yet I think that we haven't thought about these in a number of different dimensions and so forth. And a lot of the AI, a lot of the data sharing, that sort of the big data and so forth, it does bring these types of issues up. So frankly speaking, I think that there are going to be some great discussions on this to make sure that everybody really, maximizes their value and you get your value where it's due. I see Reinhardt really quickly, just in the chat, what would you recommend students to study, sort of go to college? I just want to say this is really an important thing. I think you want to avoid just saying, well, I'm going to do computer science and I'll just be a computer scientist, because I think a lot of these new tools, ChatGPT, they're going to make programming much easier. And I can give some examples on that. Maybe we can chat in the networking session, which is coming up next. but basically it's going to make it much easier. So if you just program, new tools are coming along. They're going to make programmers much more efficient, so we won't need as many. But you need to have some domain expertise. And so to me, it's domain expertise along with the programming capability. And then do you need to go to college? I would say, well, it does help and so forth, but in many instances, people are really looking for expertise. So it could be that you get some training and then you go off and you get your job. But my recommendation is that you do continue your education. So whether you go for, a year, 2 years, 4 years, get your PhD, you've got to stay up to speed on things, because ultimately, as the tools advance, they're going to be doing some of your simpler tasks that you've done. So they're going to be eating away at what you're doing, as part of the workforce. So you always need to take, to be a step ahead. And this is not unlike what's going on with automation and so forth. So this has been with us for many, many, many years. Last example I'll give you is the ATM, so the automatic teller machine, right? It's a bank machine. Everybody thought tellers would go away once these machines came out. Some very interesting papers. You can go Google it. More tellers today than there ever were, and even though we have ATMs, but the bank tellers are doing different functions, much higher level functions. They're paid at a higher level as well. So you've got to sort of move along, with the technology. Anyways, I apologize for sort of jumping to that question, but I thought it was a great question out there to some of our younger audience members.
Great. So you already answered the last of the question. Time is up. Before wrapping up today's webinar, I really wanted to thank our keynote speaker today, Professor Tom Kerfis, for delivering this wonderful talk. I also wanted to thank you, the online audience, for your participation and raising questions for discussions. Our next AI for Manufacturing webinar is scheduled on November 13 at 3 p.m. Central European Time. Professor Lin Zhang from Beihang University, China, will present a keynote on an integrated modeling and simulation language for MNS-based system engineering. Please stay tuned and have a great day, and bye for now.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the eShop, and build your personalized AI for Good program. Let's shape the future of AI for Good.
AI is a powerful tool.
This summit can help ensure that artificial intelligence charts a course that benefits humanity and bolsters our shared values.
soon.